Hey everyone, here's InterSystems developer meetup in UK. So what is it? It's a kind of meeting where developers meet developers and discuss how to make InterSystems solutions better and tell stories about that. So my name is Evgeny Shvarov. I'm community manager, and now I want to introduce John Murray. Hi, John. John starts with his story about dependencies and complexity. So, please.
Thank you, Evgeny. Thank you, everyone. I'm pleased to be here. As Evgeny says, I'm John Murray. I'm senior product engineer at George James Software, where I've worked for more than 19 years now. It's one of those alarming things that LinkedIn keeps reminding me of. I've been invited along to talk a little bit about a topic that is of interest to me and related to some work we've done in our company about dependencies and complexity. So I've got some slides here, and I also hope to do a little bit of a demo, you know, how those might go. We'll see. So here goes anyway. So this is my agenda, basically the headings for my upcoming slides. Talking a bit about treating code as data, getting information out of your code base. Then I want to tell you about a product called Structure 101 and its relevance to the cache and ensemble InterSystems world. Then talk a little bit about the architecture of code, and then about tangled code and something mysteriously at this point just known as the LSM, and I'll tell you what that stands for as we get to that slide. We'll talk a bit about complex code. Then I'll show you a product of ours called Usinji. That's the live demo risky bit. And then there's an opportunity for questions and comments at the end. So, treating code as data, also I titled it Mining the Code Base. From the earliest days of George James Software, which predates me, we've developed tools that extract information from your code, treating your code as data in a sense, and mining information out of the code base. The core engine of that, those tools is a table-driven parser, which is written in cache object script, or in fact written originally in the predecessor of cache object script. It's that old. And over the years, we've developed a variety of parse tables that this parser engine uses, and ancillary processing associated with those parse tables to meet some very specific needs. So, for example, all those years back when Y2K was on the horizon and people had a need to find date handling code within their very large code base in order to focus their remediation or testing efforts, we used the parser that we generically call RE parser. We used that to do that kind of analysis. Another example is locating global references within a code base. This, of course, typically predates the objecty way of doing stuff, but using a tool to locate global references, and in some cases doing projects where we transform those global references. For example, a project where an application was running in multiple namespaces, one for each client, and that became unsustainable, and they needed to consolidate, so effectively needed to introduce an extra first-level subscript into all of their globals. So we used RE parser to implement a project like that very successfully. Also, sometimes coding standards is an area where treating your code as something to be analyzed, identify commands that, yes, are syntactically valid, but your organization says, no, thou shalt not use the go-to command. So we can spot it and flag it up in that way. So we've got this long history of doing these kinds of things, but the results that come out of that kind of analysis, increasingly people want more and more sophisticated UI for communicating that information. And since we're a small company, we're not really in the business of being able to build large UI front ends for things. So a strategy we use is to identify other tools that we can leverage to gain the benefits of what somebody else has built and connect it in with our technology. And that's what we've been doing in this particular case. So Structure 101, back in 2012, we identified a fairly interesting set of tools available out there generically called Structure 101, developed by an Irish software company. And the tools were originally created for Java developers. But later, fortunately for us, the company who now call themselves Structure 101 because their product they're kind of known by their product. They produced what they call a generic variant of the tool, which is capable of being extended by language-specific plugins that they call flavors. So finding a powerful tool that was getting some interest and respect in the Java community and thinking, hey, we'd like to be able to do some of these things in the cache world, and finding that actually the extensibility was available there. We used our parser technology to create a flavor specifically for InterSystems class definitions and also traditional cache object script routines. So it's not just about the new classy way of doing things. It also works back into the old traditional, if you like, routines and subroutines. So it can process large code bases of that style as well. And so what we now do is we bundle Structure 101G Studio, which is from this Irish company, and our flavor, and together we call that something called Uzinji. And that's what I'll show a little bit later on. So Structure 101G Studio is described by its creators as an architecture development environment, which is a kind of new term to me when I first came across it. And I think they are, in some respects, pioneering some of this idea that architecture within your software has a significant role to play. If you think about architecting your software and maintaining the software architecture over time, that can be beneficial to your organization. So what might we be talking about when you talk about code architecture? We could talk a long time about this, explore a lot of stuff, and the guys from Structure 101 do some pretty interesting white papers and videos about it from their long experience in the field. But the two factors that I identify that I think are particularly relevant to us are modularity and connectedness. So modularity, first of all, well, in the class-based cache class model way of doing things, of course, the modularity is that we code methods and we implement methods inside classes, and we collect our classes together in packages, and we have some kind of hierarchical naming convention of our packages. That is, we don't actually have packages and sub-packages, strictly speaking. It's just a naming convention to say these packages by the dot naming convention are somehow grouping together into something a bit higher. So we don't, like Java until recently, we don't have any kind of notion of sub-packages as such. But the concept of a package hierarchy is very well established. So that's the modularity aspect particularly. And then the connectedness aspect is, well, two different ways really in which your modularized code ends up getting connected together. And I've called the first of those the definitional connectedness. For example, a connectedness of the extends variety. So this class extends that class. A definitional connectedness of the is of type dependency, which is saying this property is of type such and such, and therefore characteristics, attributes of that property are obtained from elsewhere. The returns kind of connectedness, where a method will return a value. And so those are some of the ways in which definitional connectedness, very static connectedness, appears. And then there's the second type, which I'm calling executional connectedness. And some examples here. The most common one is invokes method, where one method at some point says, hey, I need to get this method over there in this other class or whatever to do some work for me and give me something back. But there are also dependencies from queries. So when in one of your own methods, you embed some SQL, for example, and go and effectively run a query off a table, as you might think of it, you are depending on the structure of another class, which is how that table, of course, gets manifested. And back down in the more sort of traditional Mumpsy world, calls label kind of dependency, or even the dreaded jumps to dependency, where someone decides to go somewhere else, and that is establishing some connectedness between the modules of your code. So if you've got modularity, you've broken your code up into smaller units for organizational purposes, then one of the things that the guys at Structure 101 highlight is in relation to what they call tangled code. So connectedness, as we've seen from that previous slide, connectedness then leads to some kind of notion of dependency, that by being connected over there, I depend on something over there. And dependencies are not inherently bad, but you need to understand those dependencies and be conscious of those dependencies, because dependencies that you're not very aware of can return to bite you at some point. So here's that term that I introduced on my overview slide, LSM. LSM stands for Levelized Structure Map. And this really is I think, a key innovation of the Structure 101 team, Structure 101 toolset. The idea of a levelized structure map is that in a levelized structure map, you place the modules so that the dependencies point downwards in your diagram. So modules that are not used by any other module float up towards the top, and modules that are not using any other module themselves sink down to the bottom, and modules that are used by someone else and use other things kind of float somewhere in the middle, and they float to the level that works for them in terms of the levelized structure map. But if your modules, and the modules here we could think of maybe as packages in the cache environment, if your modules have dependency cycles in them, which can also be referred to as tangles, you end up on your levelized structure maps with some of the dependencies going up the way instead of flowing down the way. The contention that the Structure 101 people make is that if you, and others that they relate to in the sort of academic communities, say having these tangles, these dependency cycles, particularly at the package level, can make code bases harder to understand, harder to modify or to extend, hard to test, and also harder to deploy, because you've got these kind of what they sometimes refer to as the big ball of mud, where everything is kind of all tangled up there. Moreover, if you get new cycles starting to appear within your code base, then it's possibly some evidence that the architecture is degrading, that the architect had some big vision about how things should be, and the guys implementing it on the ground are taking shortcuts and building little walkways from this part of the building over to that part of the building where the architect would say, no, no, you're supposed to go down to the ground and come back up here again. So if new cycles appear, then it's perhaps some evidence that your architecture is degrading. If your architecture is degrading, then perhaps your whole code base is suffering from that same problem. Okay, so the next topic then is about complex code. I think it's fair to say that most software systems can be called complex. I think there are very few things that we implement in software which don't have at least some degree of complexity to them. After all, they're trying to solve some kind of problem. So complexity of itself is not necessarily a bad thing, but the challenge really is to manage that complexity. And as such, if you can eliminate or at least control regions within your code base that have excessive complexity, then you have I would contend you have a greater chance of your code surviving going forward, and you'll be able to make good use of it as the needs change over the years. So what might we say is complex code? Well, one perspective is too much is being done in a single module. Because if you do too much in a single module, it can be hard to, if you like, keep it all in mind. And there are stages within the development and support process where keeping in mind what's going on is really quite important. Make the thing too big, you can't kind of, well, the average person can't kind of hold it all in there. Another aspect in relation to complexity is if there are too many possible paths through the module, because part of the goal of modularity is breaking things down into manageable chunks. But if what you think of as a manageable chunk ends up with having 45 different ways that execution could proceed through it, then it becomes hard to understand or follow, particularly by someone coming new rather than the guy whose brain it originally came out of. But also hard to test thoroughly, because 45 pathways through there, you need that many test cases to exercise them. So what can we do about complex code? Well, it's something that, to be fair, we really need to quantify, attempt to quantify, rather than simply look at the code and say that's complex, that's simple, because one person's complex code could actually be seen as being very simple by someone else. So let's try and be objective or establish some metrics. One approach with metrics has been the simplistic sort of lines of code. If there are too many lines of code within a module, within a method, then it's too complicated, so we should reject it. The trouble with that is that the canny programmer will stick lots of commands on the single line of code in order to get more done on a smaller line count, or they'll break it down into two things that literally just kind of go from one to the next in order to get in under the radar. A more useful metric, which is quite long established in the software world, is a thing called the McCabe cyclomatic complexity metric. And one typically measures that within a discrete chunk of code, in our case, a method, to say essentially how many different ways can we go through this method. So a piece of code with no conditionals in it has a complexity, cyclomatic complexity of 1. As soon as you put an if statement in there, it goes up from 1 to 2. And if you put more if statements, the cyclomatic complexity increases. Essentially, there are this many ways of passing through the code. Structure 101 makes use of cyclomatic complexity and also some other dependency counts and counts of dependencies between modules to produce a metric that they call XS, which essentially is about excessive structural complexity. And what they're trying to do with the tool is to say these things have excessive structural complexity in there in a fairly objective way. So that's the theory. Usingian operation, well, how does it operate? You go into Studio, you launch a Studio add-in there, you choose which packages you want to analyze in the case of sort of class-based thing, or you can say analyze everything that's in my current studio project, which could be a load of old routines as well as various selected packages. Using goes away and does its business, sends the results into Structure 101G Studio. Once they're there, you have the power of that tool. Some of the things you can do optionally once you put it into Structure 101G Studio is you can publish those results to what they call a repository. And once they're published to a repository, other people in your team, or even outside your team, with access to the repository can view the information without needing the Structure 101G Studio tool. And with the repository, you can compare snapshots in order to see how things have changed over time. So for the last couple of months, we've been hosting a repository with some analysis of the samples namespace from cache versions from quite a long way back, basically as far back as I could find them lying around on my machine, right the way up to 2017.2. And in the demo bit, I'll show you some of the information on that in the web tool, but those repository snapshots have that capability. So here's where we try and make the demo stuff work. So here's Studio, and this is the brand new release 2017.2. And I'll go into the add-ins. Sorry, I'm used to using a real mouse, so it's a bit slow here. Here we are in the Evgeny add-in, list of all the packages in this namespace. In this case, it's the samples namespace. I could say, hey, I'm interested in the Wasabi package and everything that's underneath that. I can tweak some of the ways in which we do the analysis, but for the sake of the demo, I'm just going to hit the magic next button. Off it will go as do the analysis. In this case, because I've run the analysis on this code base before, it's very quick. If I'd modified any of those routines, then there will be some more processing to do because it will reanalyze anything that's changed since the last time, which typically doesn't happen with the samples database. But once I've completed that, I'll hit download results. It's producing a file, an XML file essentially, that I've pointed to Structure 101G Studio. So up comes Structure 101G Studio. And here's the initial view it's presented. Over here, I'm sorry the screen's a bit small and I haven't got all the magic for making it bigger. Essentially here then we have two top-level packages. We've got the top-level package called Wasabi, which was what I chose to analyze. And then we have a kind of pseudo top-level package called %, into which we've stuffed all the % packages that Wasabi makes use of. Because mostly you're not interested in the details of how it uses the % stuff. But we do that analysis to at least see them. And so when I look at Wasabi here, there in the levelized structure, Wasabi is above %, understandably, because Wasabi uses stuff in %, and nothing in % packages makes any use of Wasabi, otherwise there really would be a problem. And there's a little downward pointing arrow there. When I mouse over it saying Wasabi uses % 193 times. So if I wanted to see the 193 ways in which the Wasabi package made use of things in the % package, I can get what's called the dependency breakout here. So you can drill down to that level of saying who's using what and, if you like, in what way are they using it. Mostly, though, in a situation like that, you're not interested in the relationship with %. You're more interested in how your own sub-packages go here. So in this case, there are some sub-packages in Wasabi, logic, order entry, product management. But then there are 3 second-level packages, person, data, and common, which Structure 101 has identified a tangle within. That is, the 3 packages each depend on each other. So there is a cyclical dependency between those three packages within the Wasabi application. That may be unavoidable, it may be acceptable, but at least we can now see that it's there.
Sorry, quick question. Roughly how many lines of code are you talking about in this package?
These are pretty small. If I go over onto the complexity view of this one, the Wasabi package over here, this line is, again, you probably can't see the details, but this line is saying there's 1,191 lines of code in that. Its analysis of the Wasabi package is that there's a tangledness percentage of this top-level Wasabi package of 24.56%. So basically it's sort of a 25% tangled overall, that top-level package. But there aren't too many worries from these statistics. There aren't too many worries about fatness of the methods within there. There's not too much concern about how much code has been concentrated in one place. But there is this fairly crude analysis that I'm doing in a quick way, is saying there is some tangledness here within the Wasabi package that maybe with an existing code base you'll say, okay, we can see that's the case, but we don't want it to get worse. And you can use the tool quite effectively that way. Let me just, because I'm conscious of my time slot, come back over to a browser here where I can show you the 101G web app view of analysis. I've done analysis of two different code bases here. I did the samples code base, and I produced 12 snapshots of it. So I've now analyzed 12 different generations of the samples namespace. I've also analyzed 8 generations of a project called REST Forms, which has been published recently by GitHub and is mentioned on the developer community. The trend here in terms of the size, the number of lines of code within samples, this one back here, we're at like 6,000 lines of code. By 2017.1, 2017.2, we're over 12,500 lines of code. So the samples package, understandably, over the years has grown as more samples have been put in there. This measure about the XS, the excessive structural complexity, is that initially it dropped down a bit and then it went up a bit. Now, here what we're not doing really is analysing one application, we're analysing a whole series of different independent applications. So it's not a good example of the use of this technology, but at least it's a free code base that everybody's got access to, so you can actually drill in and look at the details. And so if I go into samples here and drive on my screen for a bit, say, okay, well, let's take a look maybe at the 2014.2, and by default, we'll compare that up against the previous version. So if I take a look at the design level changes in that, then there's information about what's changed within the analysis of samples, some of which is because some new packages have been introduced. The ZM Basics package got introduced, and the ZM Demo package got introduced. So they weren't there before. When we compare those two samples databases, that's an indication of some new structure, some new stuff added into the code base. Okay, so I've got one final slide on here, 2 final slides. Beyond just looking at complexity and dependency, Structure 101 G Studio, you can also use the tool to define your application architecture. Even retrospectively, you come to a code base and say, well, what was in the mind of the architect when they put these packages together? Define your application architecture, communicate that to the developers by publishing diagrams saying this is how our application should be. And then you can detect when the architecture gets violated. If you keep reanalyzing your code base, you can pick up when somebody starts doing something that really is breaking the architectural purity of what you're trying to achieve. And maybe they'll argue with you and say, we have to do this, and then you can add an exception to say, right, we're going to allow this going forwards. Or maybe you'll push back and say, no, go back and re-engineer it the way that it should do, because we don't want this complexity adding into our application. And you can also use it to model, to sort of prototype some refactoring steps, saying, what if we move these classes from this package over to that one? Will that reduce the complexity or increase the complexity or have no discernible effect? So you can try it out as like a what if in Structure 101 G Studio. And if you found a set of refactoring steps that you think will improve the architecture, you can actually provide that as a to-do list to the developers to say, I want you to move this class out of this package over into here. These are the dependencies that we're detecting at the moment. So this is the kind of thing you'll have to do in the refactoring, but we will end up with a less complicated architecture. So further information, our website, joyshades.com. The partner company, Structure 101, of course, is structure101.com. We're on the Partner Pavilion at the event tomorrow, so you're welcome to come by and ask me more about it, or you can have it demonstrated to you. Thank you very much.
Thank you, John. Do you have any questions? Questions to John? Yes, please.
Right.
Pricing structure?
It is, I do it in dollars, so it is like $995, I believe, for Structure 101 G Studio plus the Uzinji add-in to get you going on it. And it's the kind of tool you're not expecting really to give every developer, because they shouldn't really have to be working at that level. But the information that you as an architect can produce from it can then be made available to them without them needing the $1,000 tool for doing it.
Can you automate the analysis sort of on a daily basis and then provide some sort of notification of complexity
Yes.
increase or something like that?
Yes, you can.
That's probably more of a
Yes, you can. There is an edition of Structure 101G, which is called Structure 101G Build. Essentially, it's a headless version.
Yeah.
So you can put it into your build chain and say, we want to reanalyze this thing on a regular basis and provide, if new violations occur within, violations are where the architecture that you've laid out in your diagrams is no longer being conformed to by the code. And you can use violations to break the build if you want. Joe?
Will it be integrated with a target?
In effect, it is, in that it's an add-in. The thing that probably doesn't integrate at the moment with Atelier is that one of the ways in which you can drive Structure 101's or Uzinji add-in is to say a studio has. That aspect wouldn't work. But I'm pretty sure that if we fired up Atelier and said on my 2017.2 and said, look at the add-ins list, up would come the Uzinji add-in. It would do the work in the same way.
Any more questions? Actually, thank you, John. But you can, if you have any questions, you can catch John here for 2 days more and find the other wonderful products of George James, which would help you be more successful in your change management with InterSystems solutions. So thank you, John.
Thank you very much.
And according to our agenda, the next presenter is Sean, but Sean didn't make it, make it today, so I would use my advantage of community manager and make a presentation by myself. I would. So let me introduce myself again. My name is Evgeny Shvarov. I'm community manager from InterSystems, and I would tell you today about one community project which is called DeepSee Web, and which is already used heavily by several companies, and they're pretty successful with it. So it's community, of course. So let me turn on my presentation slides. Okay, let's go. Guys, just few rules. Please interrupt me at any moment if you have any questions. So it's Meetup, so it's very informal. So just have better experience, better and more conversations about the systems technology. So I'm using DeepSee. Would you please raise your hands if you using DeepSee in your solutions? Any more? So anyway, but you and who's familiar? What is it? That's much better. Okay. So DeepSee is InterSystems technology to make business analytics solutions, and DeepSee Web. It's so when you make a DeepSee solution, you have cubes, pivots, and some presentation layer with dashboards. And DeepSee Web, it's an Angular-based AngularJS web app, which renders your DeepSee dashboards. It renders in web and on mobile devices. So what are the benefits? Actually, if you have DeepSee dashboards, you can use immediately DeepSee Web. So you just open it and it shows your already prepared DeepSee dashboards in another way. It introduces some more benefits like tiles and meta design and some other themes. You can make the covers interactive, like you can have like a Tableau, or you can make the tiles of the dashboards to tell you what's going on inside. DeepSee Web has a plugin system where you can introduce almost any JavaScript applet in your dashboards easily. So picture worth 1,000 words. So let me just show it. Okay. So I install it locally, and I will show it later. So just a second. So I pick a namespace. It is samples namespace, and it is what you would. It shows the dashboards which you get with DeepSee and cache and sample out of the box. So here the green are folders, and this is just dashboards. Yes. So you can go into folders and see DeepSee dashboards like that. And why it is, I'll show you that it is a render. So I just introduce a new widget here. For example, just table, and link it to widget 1. So yes, we have just another widget here, and if we go, let's click save. If we go here and update it, so we have this new widget here. So it supports everything which we have in DeepSee. So you can drill down, you can sort everything, you can go into the lines, and here you can filter it. You can export into CSV or Excel, or make have the PDF version of that. What's good, you can share if you like this, if you want to share this one widget and introduce it in your application, in your web application. You just click here, share, and you get an iframe code to embed into your web app and to display just exactly this widget. Speaking about tiles, so for example, matters. Yes, we can we have some methods here. This is indicator, yeah, and we can go into designer, for example, and say that on this style we wanna see indicator. Yes, and you have this, like, you can format it as a tableau. And if you ask me, okay, it's samples. Everyone can do everything in samples. Show me a real application. We are using, we are using DeepSee Web in developer community. So and here you can find the production application. I'm on internet now, so which you can use every day. So it shows the current stats of developer community. So this style. So this is dashboards, DeepSee dashboards. You can go inside, for example, and see widgets here. Here. So for example, this is you can filter any date. For example, the posts with tag InterSystems Iris, our new product. And find all the posts with this tag and read it. So it's pretty usable DeepSee application. And okay, let me go further with any questions with that? Okay, let me go further with my slides. So, what is nice, you have your DeepSee dashboards mobile simultaneously. So we have iPhone app, which you can download from App Store, and it's a small video how which shows that. It connects to any server you have and with InterSystems security, and shows same samples dashboards and shows on mobile devices just without any coding. So if you have access to that, according to InterSystems security, you can see the dashboards on your mobile device in this DeepSee application. You can check it now. So download it from App Store and play with that. So okay, it's DeepSee. Yeah, so everything you have in DeepSee, you can have it on mobile devices. Okay, let me go further. So it's some demos of tiles, what you can do with the tiles. It's a demo of a plugin introduced. So if you're limited with the current set of widgets, you can introduce easily any from JavaScript libraries. You can have ton of them on the internet. And sometimes we need to put to tile some data with a map, and you can easily do this with DeepSee Web as well, on a web app or in a mobile device. You may be asking how it works. It's easy. So DeepSee Web, as I said, is Angular-based application with just a simple JavaScript client application. And to make it work, it needs some REST API, and today it uses mostly about 90%. It uses DeepSee REST API, which comes to you out of the box with DeepSee, and for some extra functionality, it uses MDX to JSON REST API, which so this DeepSee web browser asks, what are the dashboards you have here? And it gets JSON back about dashboards. Then it asks, what about widgets? And for every widget, you have an MDX query. You ask it for the server, and you get some JSON data, which is rendered on your web browser. So easy and pretty clear. the development process looks like with DeepSee Web. To develop, you just need to create normal DeepSee dashboards in out-of-the-box analyzer and cubes analyzer and designer, and then open it in a DeepSee Web, customize a bit, and deliver this customization file in a JSON file which you should deploy on the client. So, and for deployment, you need to deliver the DeepSee solution as an InterSystems cache and sample solution as an embedded technology. And you need to install on the target system DeepSee Web and MDX2JSON. And just to import this JSON file for settings. Yes, here I showed these things. There are some other nice dashboards from our customers who are using that. They introduced some very interesting, crazy plugins. And maps, yes. There was an issue using DeepSee maps because because of the Google Maps. It was the moment when Google said, "Okay, you cannot use it without paying money." So anyway, so now we're using OpenStreetMap with that. So it's okay for you to use your on any public OpenStreetMap sites, or just you can set up your own. And your own tile server, so it's pretty doable and it's free. And there are some slides. What are the sample applications you can manage with DeepSee Web and Maps? And yes, let me show you, which maybe touches you a bit. So it's we just prepared it for this meetup yesterday. So as I said, it's not a big deal. Let me check. Okay, so I need to go another namespace. So UK. Okay, here it is. And so what it does, it has the file with coordinates, and it shows it can show the data for different regions upon the value. So the value now is the population. So the red is gray, the green is light. So, and you can, for example, drill down to that and click on any region and tile the data. So it's pretty usable sometimes when you need to show some data tied to some geo-coordinates. Okay, and of course it works on mobile as well. So here there are some interesting examples. So it's map of USA. It's online. It needs some data from the server. So just let me check. Okay. Do you have any questions so far for that? No?
Sorry, there is one, Evgeny. What's the basis of the developing? You were saying it's a community-based thing.
Yeah.
That's right. Is there a license model then with it? I mean, how does one use it?
There is a license which is called MIT license, which says you can use it in a way what you want. So you can fork it today and add your code there and name it with your name and just use it. So it's just.
But keep in mind, when you're accessing the server, you're running the access to the server and then the license over there.
Sure.
Yeah. The key thing, thank you, Joe. The key thing that you should use it with InterSystems on the server.
Yes, quite.
And, which is not free, which is pretty supported and.
It's not free, but it's worth it.
brings you success and brings you the business, and that's why you're here. So what I wanted to show you, it's elections map in US. The red is Trump and green is Clinton. Yeah, so you can drill down and see the data for any. So this kind of solutions you can make it with DeepSee Web. Okay, so any more questions with that? I hope you would use it. So where you can find it? You can find it on GitHub. So it is github.com. InterSystems RU for MDX to JSON, and InterSystems RU DeepSee Web for DeepSee Web. And for the set of solutions on with map is this VW map. Okay, I'm good with that, and no questions yet. And I think I have another. So yeah.
Is this a supported product? Is it open source? Is that
it is supported by community, so it means it is not supported by InterSystems anyhow. So, but if you open this GitHub InterSystems RU DeepSee Web, you can see issues here. So people supply issues. You can see commits, 500 commits. So you are very welcome to join. And you can, if you find if people find bugs, they just they make pull requests. And so you see, we have recently 15 pull requests for this project from different people.
Does it need a specific version of Cache or DeepSee?
Yes, it works starting from 2013, I guess, or 2013 or 2014. 2013. Just from the moment when we started to work with REST API. REST, we start to deliver REST applications.
Keep in mind that the pivot tables it's using and the standard dashboards you build are supported. Those are standard things, just this interfaces.
Yes, I'm just talking about DeepSee Web, but actually you are very welcome to use DeepSee REST API, which is totally supported. And you can, as I said, it's not a big deal. You can easily make fancy UI using all the JavaScript libraries without any DeepSee Web, just using DeepSee REST API. What DeepSee Web does, it just simplifies your work. So if you already have dashboard, or if you need a demo tomorrow, you can make a nice demo with DeepSee Web. Just
DeepSee Web's a great example of what you could do on your own if you wanted to because of the REST APIs.
Yeah, but I can say that we have several happy customers who are using it in production, and yeah, so it covers their needs. So I have another presentation, so I can start. Yeah. And this is called Community and Global Masters Hub. Okay. So I'm in my next presentation. I want to share the resources you guys have at your disposal, which would help you build more successful applications with InterSystems. So what are these resources? First is online learning site. It's learning.intersystems.com. Who is using that? Who's familiar? Oh, I think this is helpful application. I like when InterSystems people raise their hands. I like that. So I like that not all the people raise hands, because so that means that this my presentation is helpful, because learning.intersystems.com is the place where you can find hundreds of online courses. Almost all of them are really up to date. And not only courses, so there are experience labs. What does it mean? So it means that we are if you start doing something with a new feature or some enroll some course, we are creating a sandbox for you. We are containers where you can play and where you can do whatever you're supposed to do with this course. So, but personally, your machine in the cloud with the ensemble or cache upon that with DeepSee. So this is called Experience Labs. What else? So InterSystems Iris courses are already there. So you're very welcome to go learning.intersystems code. It's easy. So come and start with our courses. So I hope you would like it. And the second helpful site is called community.intersystems.com. It's developer community. Actually, why it can be useful for you? So it's the place where you can find answers on any your InterSystems technology questions. So actually, what I'm doing recently, if I code something and I need a question, I just put it, not thinking very much on community, and I get in a minutes, sometimes in a minutes, answers about that. So it's better than Google. So I can promote. What else? So we are, thanks to our community, we are having articles about new successful experiences with and best practices with InterSystems technology. And what's cool that we have it every week, about 5-6 articles. I can say direct thanks to John and Rob, who are regularly, and Sean, I don't know, is he here? No. So who are regularly the representatives of UK developer InterSystems community, who are regularly posting articles about the experience with InterSystems technology. So and what else can you do there? So you can contribute and you can promote, guys, your solutions in your services. So if people see that you are a frequent answer for different questions, they say, oh, this guy have a really good technology experience and what they are doing. So they understand me, yes, because it's valuable because community is growing. And so last year we had 2,200. This year we have September we have 3,500 registered members. And actually, who are not registered anonymous, they about 15,000 of them comes to the site monthly. And in September, we had 15,000. And we have about 150 different contributors every month. So it's growing, and so please join. And I'm not asking who is familiar with community, but I hope you all are familiar. So what else? Community today, it's not on one side, so we are trying to go into different areas. We have Twitter and Reddit as a thing which attracts a bit more attention to the articles you are writing. We have YouTube channel, developer community YouTube channel, where we have the online broadcasting and some questions now. So Anthony, do we have any questions for that? No, it's not this one. Okay, thank you. But we have people who are watching it online. And we have global masters. And here I would ask you, who is familiar with global masters? Okay, I have a slide about that. So the video channel. So I invite you to go YouTube, InterSystems Developer Community. It's easy, yeah? So you can find the screencasts every week. And a screencast of how to do better something with InterSystems technology. Webinars, every other month we have a kind of webinar there. And the videos from meetups, from Global Summit, and Meetup like now. And Global Masters. Actually, what is it? I call it, it's a frequent frequent coder program, program with InterSystems. So you're supposed to earn points for learning, for watching videos, and reading articles, for sharing this content with your pals and with your social networks, if you want, of course, if you find some useful there. And we introduced the API of these global masters into the developer community. So once you contribute something, we see that on global masters, and you earn points for posting great articles and answers. And of course, it's for some fun. So there are pretty fun discussions there sometimes. And you can redeem these points for different what we are producing. So our branded stuff like T-shirts, mugs, and spinners. I don't know. But for me, I think it is much more useful is that you can have tickets for our events like Global Summit. Or please bring your ideas how we can what we can do better. So, but okay, we will surprise you with some nice rewards as well. So global masters InterSystems.com. It's easier. So it's actually it's invite-only system. But if you have WRC account, you are very welcome with this account. So you can join. Any questions for that? No questions. So hopefully you are registering on Global Masters now. And anyway, guys, if you have no questions, now we would have a coffee break for networking and for coffee. And I think some food there. And then we would continue in half an hour. Actually, it's so great to see you here. So if it would, we need your feedback later. If it would great, in your opinion, we would introduce it not only on the symposium summit, but maybe in London and other places. Why not? So if you and we have John here as a presenter and Rob, and you are very welcome to deliver your sessions. What we do.
Working a bit with that. Yes, nice.
Can I try this again? This seems to have burst into life, doesn't it? It went wrong and it...
Yeah, I think that was to do with something. Feel free. I believe it was something on the AV side.
I suppose that's... Is that a USB-C one?
I should say those two. I mean, if you so probably in Russian projects engage community, so it's more like
It's at universities.
Yes, mostly universities. Yeah. So we have a very solid research from Russia. So it's very motivation to create some great.
Yes. Well, like I think I can say.
Yeah, and I've been working on that for about 4 years. Our job was good.
Is it it's much more I guess desires now. What about the healthcare customers? Should we get some food? Do they get it with Russia Foundation?
Yes, I think
Because you do, as you said in this email, you get the situation where it doesn't look but over some parts of it already
Okay, thank you, perfect.
It's going to be more about going to be much more.
I put assignments on the afternoons. Yeah.
So it's 2 sessions, now have break and the session more and we have broadcast online. And we have more than 10 people online.
How are you? Yeah, about the same. So you've got both ways in shot, the screen and to be honest, I can't. I mean, I wasn't reading the screen. Huh? Luca. Luca Ravazzolo. Yeah, he's here. No problem. I don't know where he is, but he's definitely here. He was sitting here or here when
I want to listen to his session.
Right. He's and then next to you at the front was it's getting better. It's not perfect. It's been like 8 or 9 months already. No, it can't. It's been 7.5. So anyway, it's been a long time. But when had my last operation, which was at the end of May, and I just had one of the screws taken out. And that guy certainly said that 12 to 18 months and based on the progress so far, I think it's spot on. Because it's very slow. I mean, it's much better. Now I can stand on one leg, but my balance when I'm on that back leg is still rubbish. Compared to this, you know, I can hardly do it. Yeah, he did. He fell down off the tube. He didn't mind the gap. Yeah, well, say we are probably yeah. Well, it's better on because if every single time Elton big draws, they will right in the middle, every diagram they have to draw, not in the central exchange, but the integration gateway. Everything goes to the exchange. And they've now signed up to join with it's up there for what's the NHS called a lens, the overall event management system. And there we are. So, assuming we go with this, because we got a little bit of work to do to fully implement the ready.
Microphone?
But if we do that, then this will be very exciting. That's a very good question because well, the thing but the functionality is only available inside the information service. Yeah. No. Oh, we only do the gateway in London. Yeah, sorry. Tiana, essentially. Sorry. Okay, I'm in Blackpool. That's near there, everything's in Lancashire. But they don't like and then the other part of London is for providing their so they what you got over the documents. We're trying to move the whole thing on a little bit to say that if we just deal in documents, it isn't really going and the minute we get that, then I think we'll take them over that would be my bet right now, but it'll be a long time before that happens. It'll be a long game. So yeah.
It works, yeah? Guys, we're opening part 2 with the Tweed session. Actually, guys, if you want to listen the next session, please join. But you are very welcome to chat here. So it's Meetup. So this is room for chatting. This room for
We've got to come through here.
For the stories about solutions with InterSystems technology. And so we continue. And I can speak with that. So the next presenter is Rob Tweed from mGateway company. Yeah, am I right? Yeah. So Rob, please present yourself and tell us your story.
Sure. Okay. So some of you may be wondering about this cryptic title. A bit of background. Some of you know me very well. Others may not. A bit of history. I started with Cache back in the 80s at the Royal Marsden Hospital, where rather unusually we wrote all our applications in-house. I then became a management consultant with Shvarov, then now Deloitte's. Big project I was involved in at that time, the NHS-wide networking project, which is now all about the spine. That's where it started. I developed the business case for it. And that happened just as the internet was happening. And it was because of the internet that I then went independent. And since 1993, all I've focused on is web-related technologies. Some of the products I've created over the years, I and a guy called Chris Munt, we were the original creators of what was called WebLink. That was the original web technology for caching. I created something called WebLink Developer, which was the very first web application development framework built on top of WebLink, which is very much the precursor to CSP. I produced something that some of you may know called Ecstasy, which was an XML DOM framework, all based around cache. The next generation web application framework called EWD, which is all XML based and compiled to CSP or WebLink or also PHP. And that product is used in this application, Quest Diagnostics. If you're in the States and you get a blood test, pathology test, it's almost certainly going to be Quest Diagnostics that act as the laboratory. And the clinicians all across the US use this internet-based application to make test requests, check the results, deal with payments, and so on. It's called Care 360. It is the single largest internet-facing cache application in the world by a long margin. And it's all based on, the front end is all based around EWD. I still provide support for it. That's been running non-stop since 2007 without any security breach whatsoever since 2007. And given the nature of the information on it, it's personal information, it's medical information, there's information that if it was tampered with could kill a patient. So I'm pretty proud of the fact that that's out there. Since 2010, though, I've done nothing pretty much but focus on this technology, Node.js. And 2010 was very early days. We're now at version 8 of Node. That was 0.2 had just come out. It had only really been out for about 3 years, 2 years actually. And I pretty much have pioneered the integration of cache and Node.js. It was because of me that the cache, what's called the cache.node interface for then Global's DB, but now ported to cache, was created. And what I want to talk about today is really to give you some of the mindset that my thinking about why I work in that environment and why I've developed the stuff I have in the direction I have. About 3 weeks ago, I gave a talk to the Node.js, the London Node.js users group. And in a funny way, this is the same talk, but from a completely different angle. There, I was talking to Node.js JavaScript developers. Here, I'm talking to you guys, Cache Object Script developers. And so this is really coming at it from your direction and see what you think. So here's the question kind of that keeps coming to my mind. Is cache a language or a database. And of course, you've got a language, cache object script, and you could say, well, it's a language, and it's a programming language with an integrated database. Or you could say, well, no, it's a database, and it's a database with an integrated scripting language, which you use to manipulate that database, and that's called cache object script. Okay. Now, as a language, cache object script is showing its age. Now, this, to a large extent, isn't me talking. I work and meet up with developers in the IT mainstream, particularly in the JavaScript world. And I listen to, of the ones who have come across cache object script, these are the views that you'll get from people in the IT mainstream. It's limited, it's old-fashioned, doesn't do the kind of things that a modern developer would want to do. And unfortunately, to young developers out there looking to come into this community, to a large extent, unfortunately, it's viewed as something of a career-limiting move. If you look at the database, however, it's uniquely powerful. And what I'm talking about here isn't just the cache object part, it's the bit below that a lot of you have grown up with, which a lot of people have kind of forgotten about as well. And it's, I think we can pretty safely say it's the original NoSQL database. It predates the NoSQL movement, which started in 2009, by several decades. And a term that George James and I created to describe this database was universal NoSQL. These days you'll hear it bandied around as a multi-model database. And if you Google the term universal NoSQL, pretty high up in the list, it used to be top, it's slipped down a bit because other people have jumped on this and used it as their monikers. You'll find this paper, which George and I wrote in 2010, very soon after the rise of the NoSQL movement. And we explain in it, I recommend people look at it if you haven't seen this already, and it shows how all the four main NoSQL database types can be modeled very simply using the underlying global storage of cache. You'll see the use of the M word there, which I'm probably not supposed to utter. But to go back to the database, the thing is, in order to manipulate that database, you need to learn its scripting language, cache object script. And in my opinion, it's the largest single reason why when I go around in JavaScript meetings, Node.js meetings, not one person I talk to has ever heard of cache, ever. I've not met anyone yet. When they say, what technology do you use? Oh, I use something called cache. Never heard of it. And part of the problem is that in order to use this database, which is way beyond anything in my experience out there in terms of database, you have to learn this language. Now, people have talked about a solution to this, and one I keep seeing recurring, and it's been coming up recently in the community group, is we need to modernize that language. We need to bring in new language capabilities. We need to bring its syntax up to date and so on. Create an ecosystem of functions and whatever. And again, in my opinion, that's not going to get us anywhere. Nobody in the mainstream of IT is going to learn a brand new language these days. They're going to expect to use one of the mainstream languages in order to access a database. And if they don't see a modern language, they simply will ignore that database. So let's just go back to that question about language or database again. Is it first and foremost a database, or is it first and foremost a language? And I think that misses a key feature, which is really provides the real power to cache. And most of you guys who have kind of grown up in this since the year dot take it for granted, but I can assure you nobody in the mainstream of IT get it. What am I talking about? Well, I think it's described like this. So if you ask what's a database, in the mainstream of IT, it's that thing over there that we access. That's got our data on it. Whereas I'm over here in my programming language, and we want to use that database that's over there. Right? And so it's a separate server, it's a separate subsystem, it's accessed typically over a networked connection via some protocol. People are using REST these days, or TCP/IP in the past, SQL as a syntax on top of that, but it's over there. Okay. Whereas if you look at cache, it's here, it's all there. It's this blurred distinction between what's the language and what's the database. And by having this separate database idea, and this is what happens in the IT world, it's created an explicit distinction between guys who are programmers and database guys. Now, some people span that, but I know people who are programmers who are clueless about databases. And similarly, I know database guys who have no clue about programming languages. And it creates these two separate disciplines. And the unique feature we have in caching is the underlying global storage. And it's unique because it blurs this distinction between what's permanently persisted and what's in memory. And those of you who have used the old underlying language, and it's still available in cache object script, know that the only difference between accessing stuff in memory, which is what we call sparse arrays, or on disk, which are identically structured sparse arrays, is a preceding little character and up arrow. And that's all you need to do. And that now says it's on disk or it's in memory. There's nothing else out there like that. And we take it for granted that we've got this intimately connected data persistence. And so I'm going to revise the definition of is it a database or is it a language, and say it's a language with data persistence. So it's a seamless language feature. But here's the problem: that language to the IT mainstream is obsolete, and it's a barrier to entry. So the question: could we add a modern language as a first-class alternative to cache object script with a similar concept of data persistence in a similarly seamless way? So an equivalent in that language to up arrow, but in a way that is centric to that language, okay? That it's not, oh, well, you're using these things called globals and you haven't got to learn about them. No, this is, can we do it in a way that that language developer would say, oh, that's cool. That's just our in-memory structures on disk. So, of course, that begs the question, well, what language would fit the bill? Now, this begs the question whether it would just be one, but let's assume it's going to have to be just one because of the resources needed to do this kind of thing. So from the mainstream IT perspective, you're probably talking about one of these guys, the big languages. C and C++ are probably too low level for this kind of thing. So you're probably talking about these guys here: Java, Ruby, Go, Python, JavaScript. But from our perspective, if this is going to be viable, it would need to be as fast as native cache object script. Otherwise, there's no point in doing it really, because that's one of the features of cache object script is its blistering performance. And you'd want it to be equally fast for general purpose coding and also database access. And even on a most basic machine these days, you can easily set over 1 million global nodes a second through cache object script. So you want that kind of performance. So you'd also want a language that's suitable for all the kinds of things that cache object script is currently used for. So your desktop, your mobile, your browser, batch processing, don't forget that stuff. Cache out there is used in all those kind of environments. But we want to be able to do this mapping to the global storage in a seamless way. So what I'm saying here, commonly accepted native in-memory representation with that language. So in other words, whatever mapping we do, it needs to make sense within the context of that language. So we need a language that doesn't have an impedance mismatch to stop that kind of thing being possible. So let's have a look at the key features of global storage that we're going to try and map. So it's schema-free, it's hierarchically structured, and of course it's all dynamically created and destroyed. You don't have to define a schema or anything like that. You can just build globals on the fly, and you can extend them and augment them, do whatever you like. So it's ideally suited for what we call late-bound access. So I've just thrown these together. You can argue about the detail. I'm not going to go through them in detail, but I just kind of threw together some matrices here. So Java, well, it's a nice fast language and it's well used, but it's not the language that the problem is it's designed for pre-compilation, so early binding. It's obviously used around the cache classes, but we're talking about something that's completely dynamic, and that doesn't naturally really fit. Ruby, big problem with Ruby is its speed, and it's a bad choice for mobile development in the main. It's got, people like it, but I don't think it's what we need. Go, yeah, it's nice and fast and so on, well liked by its users. It's not used in the browser, so otherwise pretty good. My question with stuff like Go is, with anything from Google, are they going to support it in the long term? I'm always very wary of them. But it's an interesting one. Python, again, could be an interesting one. It would fit in many ways, but it doesn't have great performance, to be honest. Which leaves this guy here, which is the one that I believe is the best fit. JavaScript. On the server side, Node.js, it's very high performance. It's hugely popular, keeps growing in popularity, and JavaScript objects map beautifully onto global storage, as you'll see. So, we can argue about this in the bar later, but I made the decision, of all these languages, JavaScript just seemed to be the natural fit. It's an interpreted language, just like cache object script. It's loosely typed in a similar way, and it has the JavaScript objects, which you've got this term called JSON, JavaScript object notation. JavaScript objects, they're schema-free, dynamic, and hierarchical. This is interesting. And so if you take a global, here's a snippet of a global, just some arbitrary one, I've shown it there as a hierarchical structure. You can map that global to that JavaScript object on the right, and vice versa. In fact, the only thing you can't do, the only mismatch, is that in JSON you can't have data at an intermediate node. In globals you can. But apart from that, it fits. You can map any object. So a subscript in a global maps to a property in a JavaScript object. So that global on the left can be represented by that JavaScript object on the right. Well, it could do, except the JavaScript object's in memory, not on disk. Okay. So there's the question. Could we do some kind of a trick where we can abstract these guys so that they appear to be those guys on the right? Effectively, the JavaScript equivalent of the up arrow. And this is one of the key things I've worked on since those early days. And it's a module, it's on NPM, it's all open source, it's called EWD Document Store. And it's a JavaScript abstraction of global storage. And it abstracts global storage as two things, actually: a document database, a really rather unusual document database, and what I call persistent JavaScript objects, the up arrow equivalent of cache object script. So here, I'm not going to go through this in detail, but you declare these things called document nodes. So they're the key to it, a document node object. And that represents a node within a global. I don't call them globals, I call them documents, because again, globals in the mainstream of IT have a very different connotation. So whereas documents are, I think, are a much better fit. So it's called the document node object rather than the global node object. And here's the key to this. That document node, global node, represented by that object, may or may not yet physically exist. So this doesn't create a node, it's just creating a pointer to it. Okay, creates an instance of an object, but that document node object has with it all the properties and methods to manipulate that particular global node. Okay? So you can do things like this. You can declare that document node, and that represents that global node there. And so to create it, we can say just dnode.value equals whatever. To get it, we do the reverse. So value is a read-write property. So dnode.value gives us the value of it. You can delete it with dnode.delete. And just like in global storage, that'll delete all the subtree below it. We can test if it exists, dnode.exists, that returns true or false. So you can represent any node within a global as one of these guys. And then you've got things like, so this one you can determine, does it have children, does it have a value, does it exist? We can go to the leaf one, and that'll give you the different values. But we can even go to this one here, which doesn't actually exist in here. And of course, if you ask those, then they're all false. Okay. We can traverse documents. So instead of using the old $order, once we've set up a pointer to a document node, we can use the for each function, and it triggers a callback, what's called a callback function in JavaScript for each of the subscripts. So the first time it runs, this argument of the callback function node name will be F1, second time F2, second time F3, and then it falls off the bottom, and there's our results. As a document database, you've got two methods called getDocument and setDocument. So if I have this global here and set a pointer to it, a document store pointer to this top level, then if I say my obj is doc.getDocument, bang, that just creates that JavaScript object, just like that. Okay, and so my obj is now an in-memory instance. This is like a merge to a local array, which is the basic equivalent of that. And we can do the reverse. So we can take an object, instantiate a JavaScript object in memory, and then set a pointer to a global node that doesn't yet exist, and then use the set document on that and pass in the JavaScript object, and bingo, out comes the global. Oops. So it's bidirectional. Now the other cool thing about this is where I'm using getDocument and setDocument, the document database methods at the top level, but I could have pointed to any level within an existing global, and getDocument would get the subtree, and setDocument would push in a subtree. So again, it's just like a merge, only we're dealing with JavaScript objects here. So okay, so what makes this possible? Well, at the heart of it is the cache.node interface, which is part of Cache, and it's included in Iris. Cache.node is an interesting interface. It runs as an in-process connector, and it connects directly to the C++ call-in interface of Cache, which means it's directly connecting to the heart of the global database. It's the lowest level connection you can get. So it bypasses all the language interface straight into the global engine. And therefore, by virtue of it being in process and directly into the database engine, it's incredibly fast. So here's a process in blue. You've got your cache process there on the right. You've got your Node.js process on the left. They're one and the same process, and cache.node is connecting here. So all this JavaScript that I was showing you earlier is taking place in here, and it's accessing globals in the case of what I showed you, but it also gives you access to functions and cache objects as well. So cache.node is pretty powerful, but it's a very low-level set of APIs that come with it, and it all hinges around the basic global primitives: set, get, kill, and so on. So remember what I said before about we don't want, if we're going to do this, what you don't want is access to underlying global storage in a way which isn't natural to the JavaScript developer. These guys, these globals aren't natural. They think in terms of JSON, JavaScript objects. That's the way they think. So the APIs that exist on cache.node are not what we want, not JavaScript centric. So EWD Document Store builds on top of them. So underneath them are the pure APIs used by cache.node. And I've just created this layer above, all in JavaScript, to create this JavaScript-centric mapping. And I really believe that what this has resulted in is the JavaScript equivalent of that up arrow. You've got local JavaScript objects, you've got persistent JavaScript objects, and you're manipulating JavaScript objects on disk through JavaScript objects in a way that's perfectly natural for a JavaScript developer. And I think pretty good for a cache developer as well. George James is someone you might want to ask about his experience of using this stuff. Now this is all very well, but there's a problem, and that's the Node.js architecture. And those of you who know anything about Node.js will know that everything executes in a single process. So you can have thousands of users, but they're all in one process, all sharing it. And it's by design. It's the brainchild of this guy, a guy called Ryan Dahl, who ironically no longer uses Node.js, he uses Go. But let's not worry about that. When he developed Node.js, he wasn't setting out to create server-side JavaScript. He was setting out to create a single process environment for very high performance networked applications. And he's not actually a big JavaScript fan. If you read all his talks and everything, he's never liked it. But it was a means to an end. He realized that what he was trying to do needed a language which was exactly the way things work in a browser. And the Google V8 engine had been open sourced. So he used that and built the language interface to Node.js in JavaScript. So it's server-side JavaScript, not by design, it's by accident. But it means that Node.js is all revolving around his original concept of the single process doing everything. Okay. So the way in which this manages to cope with all this activity, simultaneous activity, is through two things, which are called non-blocking I/O. So when you access a disk or data on disk or go out to a website or whatever, you do it in a non-blocking way. And you also do things in an event-driven, asynchronous logic way. So you create a request for the file, and the JavaScript carries on doing its next thing. And when the file resource is available, it triggers a callback event in JavaScript, and at a convenient point, it'll carry on and do the processing of the data. So it means that when you're working with Node.js, you start to have to understand asynchronous APIs and asynchronous logic, which can be fun. Now we've got a problem because this EWD document store requires synchronous APIs. It just has to, because things like what you're seeing here, it requires the chaining of functions. And it has to be done in a true synchronous way. You can't do it even through the new, what's called a wait async mechanism. It would be horrible trying to do it. And if you look at that get document and set document methods, those absolutely rely on synchronous logic. And the problem here is, in Node.js terms, is concurrency. The fact that all the concurrent users are sharing the same process. So the question is there a way to avoid that? Is there a way to create some local environment where my Node.js, my JavaScript code running in Node.js, runs in an isolated container, so it's got it all to itself, and so concurrency isn't an issue? If we can do that, then we can start to make use of this module that I've created, right? And that's where this thing comes in that I've been working on for years. It's now called Qt.js. It's a Node.js platform and framework for application development, where an integral part of it is that data persistence as a feature. So a multi-purpose Node.js runtime platform, and it creates an isolated runtime container. It's the reason I developed it, was to be able to create this environment where you could run this stuff here, and by the way, as a secondary benefit, it gets rid of another problem which is rife in Node.js, and that's long-running CPU-intensive work. So I built Qt as a way of creating an environment in which I could create this JavaScript with persistence. So very quickly how it works, it's a master process and a pool of worker processes. And the master process handles all the external side of things, all the incoming requests, either over REST or WebSockets, come in through the master process. And it also returns the responses to the client, but that's all it does. All of the work, all of the real work is done by a pool of worker processes, and they're what connect to the database. What happens, the master process, any incoming request is immediately put on queue, and the message is dispatched out to an available worker process, and a worker process can only handle one request at a time. And this is all part of another module that I created. Again, it's an open source module. It's called EWD Qoperate. It can run standalone, but Qt has been built on top of it. So here's how it works. Here's the master process, and it's got two interfaces outward facing. A web server to provide the HTTP or REST handling, and something called socket.io, which handles WebSocket interfacing. And it also has a queue, so requests go on the queue, and as soon as they go on the queue, it triggers an event which processes the first message in the queue. And if no worker process exists at the time, then it fires one up. And then all the associated stuff that's needed by that worker process, like the interface to the database, is attached to it automatically. And then the request is passed to it. And as soon as that happens, it makes itself unavailable to the pool. So the next request that comes in will get queued, and it will trigger a new worker process. And that'll continue until your worker pool size has been reached, and you decide how big a worker pool size you have. So each one of those workers now has the connection to caching. And they're all busy, so now when a request comes in, there's no more workers available, pool size has been reached, so that'll just sit in the queue until such time as one of those becomes available, and then it will pass that request to that available one, and that'll become, that'll start working. When your work is finished, you invoke a function called finished, and that does two things. It sends the request back to the master process, which dispatches it back to the client, and it also returns the worker back to the available pool, so it's ready for new work. If any of you know how WebLink works, and indeed the CSP, core CSP work, it's exactly this. Pretty much WebLink only written in JavaScript. And it's actually a fairly tried and tested architecture in computing terms, this master and worker process. So the key thing here is that the worker processes are persistent. So there's no teardown and startup cost. Typically, there's about a 30 millisecond cost in terms of starting up a Node.js child process. So the master process is pretty much the perfect Node.js application. There's almost no CPU intensive code. The requests come in, stuck on a queue, and processed. And when a response comes back, it ships it out. Whereas all the work is done in the worker processes, and it's up to you to have as many of those as you want. And what happens in those is completely isolated, so there is no concurrency issue. So now you can create and run these very high-level synchronous database APIs. So this combination, queued, EWD document store, actually EWQ operate as well, and cache.node, they result in what I was trying to set out. JavaScript is a first-class language for caching, and it really does provide, in my opinion, the JavaScript equivalent of up arrow. And so what we've now got, and nobody else has been able to do this, JavaScript with data persistence as a language feature. Okay. Now the problem is, I know if I presented this to JavaScript guys, they wouldn't get it. And part of the problem is there's one remaining issue, and it's down to performance. I said that the cache.node interface is very high performance. Potentially it is. Potentially it has, there's been some tests done on it with other languages. It actually can run faster than native cache object script. In native cache object script, it's easy to get over 1 million global nodes a second. You can write a little loop and try it sometime. If you do the same thing in JavaScript with cache.node, you get only about 10% of that performance. That's a big, big hit. And the reason is a bottleneck in Google's V8 engines API that have to be used for the access to cache.node. If you talk to a Google guy or a JavaScript guy or a Node guy, they'll say it's insignificant. It works in nanoseconds. What's the problem? And the problem is that they're used to a database being that thing over there, over a network. So that thing takes a finite number of nanoseconds, milliseconds to return its data. With this, we want it to be ridiculously fast. And unless we can get it because we've used cache with this very intimately connected database, I can assure you people in the mainstream of IT don't get it because the database is supposed to be over there. And the tiny amount of overhead that's in here really becomes significant when you do a lot of work through cache.node. If it can be fixed, what we'll have is, without a doubt, the fastest Node.js connected database on the planet by a significant margin. It'll blow away something like MongoDB by a significant margin. And we'd have data persistence as a feature of JavaScript, which is unheard of. And if we can get that kind of level of performance, we can go out to those guys and help them get it and show them, look at this. There I'm creating objects in memory. Now I'm creating them in disk. And it's almost the same performance, right? And that's what we're used to. We can get them used to it. Now, can it be fixed? It'll probably, to get the correct fix, it's going to require Google to sort it out. It's been logged on their bug tracker for about a year, but there's no sign of them doing anything about it. Basically because they don't get it. They don't understand why it's this. It's not, to them it's low priority because to them they look at it and it's bloody fast. But it's not fast enough for us. Watch this space. I've got a plan B starting to be put in place. But if it can be fixed, this is going to be huge. I've absolutely no doubt about it. And it's the reason why since 10, that I've been working on this stuff. Because if this can be done, this is massive. And all of us stand to benefit. Because one of the things it means is you can bring in new guys, JavaScript developers, start working and be productive from day one instead of, well, you're going to have to learn this thing called check cache objects. This is huge. So that's my Barrow Redux data persistence as a language feature. I think we've got to do it. Thank you.
Any questions for Rob?
Just a quick question.
Sure.
And I don't know this technology very well. What stops two things updating the same piece of JSON at the same time?
Well, the fact that you can't have data in a leaf node. Sorry, you can't have data in an intermediate node.
Say in the queue, two things follow and they went into separate. Can't remember what you call it.
Concurrent updates to the same global node.
Oh, right. Well, for that, you just as in normal cache object script, you would use the lock because it's synchronous. You can use a lock, and it's one of the commands that you have available to you. Yeah, that's one of the cache.node applications, so you have access to that. Yeah. Any other questions?
Some more questions?
Do you actually, the actual blockage that's in Node.js, what's its nature?
It's not in Node.js. It's in the core V8 engine. What's called the V8 engine? It's the implementation of the JavaScript language that Google have created, and it's the API that they create for external access. And to be honest, we're not entirely sure why it is as inefficient as it is, because it shouldn't need to be. There's an awful lot of something happening underneath. Now it is open source, so part of plan B is to actually go into the open source code for V8 and try and figure out what the hell's going on with it, and see if even as an interim we can do some kind of fix that we can go back to Google and say, look how much faster we've made it go, and kind of shame them into doing it, make it a fait accompli. Because as I say, if you go through that same cache.node interface and bypass Node and go in through another language like C++ or Java, it's as fast, if not faster, than native cache object script. I mean, it's insane. So it's just that bloody V8 API. It's so frustrating. I've known about this for about 5 years, this API bottleneck. It just drives me nuts. Because it's everything else is there. We've got everything else there.
Is V8 the only implementation?
No, Microsoft have one called Chakra Core, and they're moving all their stuff, because they're big in Node.js now as well, Microsoft, and they're moving all their stuff now over to use their Chakra Core engine. And I don't know yet whether their equivalent API is as slow or faster or whatever. Unfortunately, I'm not a C++ developer, so if I was, I'd have tried to sort this out months ago. So I'm kind of reliant on other people to help out, which just adds to my frustration. But Chakra Core could be, I don't know. The last time it was looked at, it wasn't particularly performant, and Microsoft admitted it was just out of the starting gates, really. But they've really tightened it up now. They're getting good performance, apparently. So, and there are really no other server-side JavaScript environments. There was one called Nashorn years ago, and Netscape, they produced the very first server-side JavaScript way back in the mid-90s. But both have kind of died because Node has just steamrolled a lot of them.
Beyond this issue that you have at the moment, what are your plans for this going forwards?
I'm not sure. I just kind of do this stuff because it has to be done in my view. No one else is going to do it, so I just think, well, I'd better do it then. In many ways, I keep, by doing this stuff, I keep reinventing myself, and for me, this is a means to an end to get consulting and training work, which keeps happening. And the more people in the JavaScript and Node.js community I can get latched onto this, then the more work I can get. Because that's where I see my work coming from, not unfortunately within this community. The amount of work in this community for someone like me is becoming more and more limited. Whereas it's out there is huge, potentially. And if this can be made to happen properly, then someone's going to have to be the champion out there to cheerlead it and become the big name. So.
One last question.
Sure.
I agree with your point that Cache is a fantastic NoSQL database, but yet if you look at the Gartner reports, whatever, it's not in there.
No, it's not in there.
What is the one thing that you think could be done to really change that?
I think it doesn't appear in Gartner and things like that for the same reason that when I go to JavaScript and Node.js conferences, no one's ever heard of it. And it's not because there isn't marketing. I mean, there's plenty of marketing out there for Cache. I think it's seen as too much of a niche, and I think the language, like I say, is one of the problems. You know, if someone I talked to at a JavaScript conference went to look, said, "Oh, that sounds interesting. I'll go and Google it." They'll discover that pretty quickly that it's got this language that you need to use. They'll probably find that it's not called Cache Object Script, it's called nonce. And then they'll look a few further down and they'll come across a link to something called the Daily WTF, which when you go into there, you will see a thread written by, as it happens, I think from what I've been able to figure out, they're mainly ex-Epic developers. Thousands and thousands and thousands of people just ripping into lumps of language, and very quickly that guy that I have talked to will go, "I don't want to touch it. I don't want to touch it. It's poison." And that's a big, big problem. It's a big, big problem. And that's one of the reasons why I call these things documents, and I never mention the M word. It's got to be JavaScript.
But anyway, Cache Object Script is the best in the planet language to deal with globals still.
Yes, still it is. Still it is. Yes,
yeah,
it is.
and one last question. Anyone? So anyway, you can catch Rob here for 2 days. So thank you, Rob, very much. My just small question: where do you need such a performance with Node.js? So maybe we can solve it with some other technologies, like with containers and microservices. So, and it's a question, and also it's an invitation for the next presenter, for Luca Ravazzolo, who is a product manager of InterSystems, and who would tell us about how you can build your solutions with containers and InterSystems Iris data platform. And what is good about meetups, what I can say, that you can tell anything, you can tell any stories about how to work with InterSystems technology and your vision. And sometimes this vision cannot intersect with InterSystems opinion on the things. And this is great, I think. So, and that's why we are doing that. And thank you, Rob. This was very interesting and exciting. And I would expect your more contributions to the developer community, and maybe to solve this problem of 21st century, this V8 bottleneck. Yeah, and anyhow, it would lead to more great applications with InterSystems technology. So, Luca, okay, we can start. Okay.
Hi, everybody. Good evening, and those online that are watching, probably a couple of them, maybe more, we hope. So if Node.js is very famous, there is another technology that's actually taken the infrastructure and the infrastructure by storm, let's say. This is called Docker containers. How many of you have used Docker containers? 1, 2, 3, 4, 5, okay, a few at the back there, that's good, great. And I was thinking, well, I could tell you all the good things that we've done at InterSystems, right? But, you know, for the majority of you, as there's only a percentage of use containers, I think we're gonna miss some of the values. So I just wanted to introduce a little bit why containers are interesting if you haven't had time to have a look at it. So Ford said, we'll have to feed them something else, these horses, right? If we want them to go faster. And the point is you have to think laterally. Literally you have to just leave the old paradigm and think in a different way. And this is in a way what's happening with containers. And although they've not been around, they've been around for many years, so we can trace it back to the old CH root in 1979. Only Docker in 2013 in Paris, they started in a garage in Paris, make them available and easy to use for everybody. And the real problem that they solve is how can I move my application. We started with a great tool from John earlier on this afternoon, and say I got my code. Say, how can I give you my code and make sure that it works? Because I'm a developer and it works on my laptop, right? Of course it does. And I got the latest of the library that I wanted to, and I fixed that V8 problem, and it goes even faster. I haven't benchmarked it, but it goes fast enough on my laptop. How can I make sure that when I give it to you, you run your testing, I go in pre-production, I go into production as well. How can I be 100% sure that it runs? How can I guarantee this? And this is basically the fundamental issue the container solves. Okay, but there's lots of other things. Okay, so what is a container? It's a portable standard bundle that is runnable. Okay, and the standardized bundle, okay, that we freeze up, we call it an image. And when I run that image, that is the container. It's the executing state of that container. It fundamentally leverages what is in the Linux kernel. So Docker hasn't actually invented anything new apart from an API and a nice command line interface. It leverages two fundamental features. One is the namespace, and the other one is called the control group. So namespace allows me to kick on a process inside a container, and I'll start with PID1, PID2, so all my processor and IPC, the process communication, and shared memory, everything is segregated, particularly from that container as a startup. And the other part is because we want to be good neighbors, because I can launch probably 100 containers on my laptop here instead of 2 VM maybe. I can make sure that all these containers only take a percentage of the CPU, in particular so much of the throughput of my networking, so much memory, etc. So I can limit with the control group how they can take resources. And because time is really running out, because I'm the one between dinner, right? I thought that I just run some container commands, so you see the speed, the agility, and then we're going to try to underline some of the other benefits of container. So let's make this a little bigger. Can you see that? Okay. So first of all, when we talk about containers, sometimes it's synonym with Docker these days, because we can find it everywhere. I mean, literally everywhere. So all public cloud infrastructures, public cloud, so AWS, Azure, Google Compute Platform, they support it. So much so that Azure came out with the second actually container-only service. So you have this CAS, C-A-A-S, for container as a service. And what's the point of that? Well, the point of that is I don't want to look after the OS anymore because it's a pain in the butt for me. I'm a developer. I have a solution. I just want to promote my endpoint, my socket for my service, and that's it. But I still have to look after it and be an expert in Red Hat or whatever. Well, you can create your container, spin it up in AWS or Azure. It's got actually 2 of these services right now from August, quite interesting. And on Google, also on premises. Okay, so if you work with OpenShift, Red Hat, or OpenStack, or any of those kind of environments, even VMware themselves, they have 2 container services inside VMware that you can use now. And the nice thing, so you find Docker everywhere. Okay, so what do? You just install a service, you have a daemon, and after you have that, you can just list the images that you have there. So I've got some images. You see some of them, from InterSystems internal, some from some other places, and let me just run a command then. Let's just run a container, right? And I'm going to do it live. So let's hope that everything works. So I'm going to do docker run busybox, and I'm going to do date. Okay. So it's asking my engine here. Well, I can't find it here, and this is the risk of running things live. It's trying to connect and pull busybox as a container, and so it's pulling different layers of it, and it's slow on this generic Wi-Fi. But here we go. It's run. So that's the date they run. So I told him to run a particular container. It's called busybox, and I told him to run a particular command. It's called date. So it just done that. And that time, that lag that I was embarrassed about because the Wi-Fi is really slow, it was the time to download the container. But if I run that again, that's the type of timing. So what that command did is it ran a container, okay, instantiated the image. This time it found it on my machine, and it ran the command I told him to run. So that was pretty good. But you might have heard that containers are ephemeral, right? And so they exist just for the time they're up. That's correct. That's what happened there. I have no containers running here. If I do docker ps, there's nothing there. Although you might find that there's a couple running there because I ran it twice. That they ran, they did what they had to do, and now they're stopped. So I'm just going to remove them quickly. Okay. So we don't have sleeping containers anymore. And what I could do then now is run the same container, docker run, busybox, and instead of running date, I'm going to ask for a particular command that's called a shell. I need to remember interactive and give me a sudo tty. I'm inside the container. Okay. And so what do I have inside the container? And by the way, this is about 1.1 megabyte busybox. A standard distribution of Ubuntu 2020, CentOS 199 megabyte. I'm talking about megabyte, not gigabyte. And that's, so what do you have inside? You have just a minimal operating systems without a kernel. I don't need a kernel. Why? Because I'm using the kernel of the host me. Okay, so that's how. And so those two features of the kernel, this namespace and the C group that we talked at the beginning, it leveraged those for me to be able. So I can touch a file here. Let's call it file it out. And we see that it's right there. Okay. And of course, if I exit that and I run the container again, it's just not there anymore, right? However, because that container is slow down. Because that container has it's just gone to sleep now, I could commit that so I can find my my file.out that I just touched. And then all of a sudden I have a new layer. So it works by throwing layers into this. Is my time over already?
No.
Okay. All right. So I was trying to rush, but dude, that's fast. So let's do my app. I'm going to cd my app, and I'm going to build an application. Okay. So we call it my app.sh. And we're just going to do something simple. The Meetup. Okay. Let's get another line there. Get the right command. I help. Okay. Okay, let's run it, make sure our application works. So, okay, QB did its job. We'll correct those errors later. And I wanna put my app, and this could be my JVM, my Node.js, my cache.dart, my Iris, InterSystems Iris data platform in a container. Okay, so how do you do that? Instead of keep doing committing and putting new layers every time I copy or touch a file, the example I did, I can just use a Docker file. Okay, so I can do Docker file. A Docker file is just a definition of what I want in my container. So I wanna build it from busybox, just because it's nice and small, and I wanna copy. We're in this path, so it's called my app.sh. I wanna copy in root, and by default I want it to run my app.sh, for example, right? So I have this Docker file, and all I'm gonna do is Docker build. And we tag it, we're going to give it a name, busybox v1, for example. Yeah, you need to tell it dot, it helps. It means in this directory find everything that you told me about in the Docker file. Okay, so now if I do Docker images, I got that BB, where are we? BB version 1, we type the v1, for example. So now I can just run that, so I can do Docker run, BB v1. That's our app. Dockerized. That's as fast as it is. Okay, but not only that, then I could do Docker push, for example. I need to rename it first. Docker tag bb v1 to my Docker hub bb v1. Okay, so what happened there? I just renamed it. So there's a new repo with a new name over there. So now I can just Docker push it, but we'll leave it because the network is terrible. So Docker push is now dash bb v1. Okay. So it's just pushing it over. I mean, the upload is as fast as download, so it's going to take the same amount of time. And that was fast. I told you, it's exactly the same, less than a megabit. So what happened is that if I do a refresh in my Docker hub, I find myself with a new BusyBox application. It's private, so I need to change it. And download is slow. Let's make it public, for example. Quick. We don't have much time. It's not working. All right, I'm gonna give up. Anyway, the part of the demo was, I show you that I've got a hub on Docker Hub, and I can go on Google and pull it from there, and you just package the application. The point is, and this is the very, very important point, everything my application needs is all the dependency that I need from my application are worked out, are satisfied at build time when I do that Docker build. Okay, so let's go back to our slides. Try to highlight some interesting things. Okay, the focus is definitely on the application. Okay, there's a strong separation between code and data. So in my Docker container, I typically have my code. So the more you have separation between your code and data, the better. Okay, so I could have a cache or that just holds my code. So I put that inside the container, and my actual data, well, I map it out to a volume to the host, where maybe I have a SAM storage or an EBS, Elastic Block Store in AWS, etc. And the other important point is that there's a difference between what is the build time and the runtime. And the build time, I don't build my production system when I'm on the cloud, and I got my EC2 instance, and I'm figuring out all the libraries from my Red Hat and my dependencies. It doesn't work now because my developer did tell me, I forgot that he wants Python 3.2 or a particular JVM version, etc. You actually build them at home on your provisioning pipeline. So the idea is, trying to go a little faster, is that when I work with cache, the question is, how do you provision, how do you build your application, how do you deploy it? So there's about 1,000 ways of doing it, right? And people who work with Java is probably the same thing, apart from saying I've got everything on the JVM. Well, okay, we could have everything in the cache.dat, but I have some code, some class in my XML, there's some routines, some globals that I put together, some scripting to actually install a pipe into C session, whatever I'm doing, right? Versus the CPF, I want a different CPF. Why do you want a different CPF? Because in testing, I have some particular value. In production, I've got different values for global buffers, etc. And so you end up with a bundles of files, or maybe some big files as well that you want to ship. And they say, here we go, QA, quality assurance department, go and run it. And what do they actually do? Well, actually, they're testing that all this process works more than testing your code, right? Why? Because that's the nature of the beast, right? You have a series of dependencies, there's a series of steps, a series of shell script and XML file that you're doing. And then what happens is they are the one, and they're not necessarily the people, the architect, the infrastructure architect, that tell you, well, you must do a series of things. Why? Because I'm provisioning a new system out there in AWS, in Azure, in GCP, Google Compute Platform, but it could be on your VMware, right, on your on-prem. And you say, okay, I'm preparing this, nobody touches this, only my best system administrator, this is Red Hat, 7.3, 0.1, because we've got a couple extra libraries for security, and then you start applying all of this code. And okay, we have CM, configuration management tool, but even with those tools, you get into problem because you get into system drifts, because they find that the CM that you run here runs differently on EC2. Why? Well, because the AMI, the image that you provision, is slightly different. It's got different libraries. So they either stop, don't do anything, you don't know, and you get into system drift. Well, what we're saying here instead, if I work with containers, my build system, my build phase is right here. As the developer gives me the code, okay, you use whatever you use in terms of your source control and Jenkins building, etc., anything you want. But at the end of the day, that build phase is done under your control. And guess what? As soon as it comes out, you put it in a registry, like you saw me doing the Docker images, I did a list of my registry, but maybe a registry wide for your corporation, organization. Guess what? I'm going to give that exactly that artifact, that image to developers. He can't play with any version of Python that he wants or any library. He needs to tell me if he's got a different dependency because he's developing something new. So that we factor that in when we build it. So everybody uses the same artifact across it. So guess what? When it's time to run in the cloud, on-prem, or in a public cloud, there's only that artifact that runs. And it's exactly that. It's been a repeated process. We are 100% sure what is running. Okay, so the focus is really much on the application. That's why people are going crazy with this, because there's a lot of value. So much so that one of the first market research that came out from RightScale in March of this year, they had this bar that you read through and you say, Docker is replacing configuration management tool. I said, nah, there's a mistake here. It cannot be, right? Docker is not a configuration management. It doesn't configure a system, an operating system. But why is it replaced? And I had to read the page twice to really understand it. The point is exactly this, that why would I risk to have system drifts in all these various environments, right? So to test, UAT, pre-production, when production, and you're never 100% sure if they're exactly the same. Yes, I can copy VM, but when you start using configuration management tool, you just get into system drifts, as things do change over time. Well, here, I know exactly what I have, okay? And so people are just saying, why the heck should I use configuration management tool? This becomes my configuration management. It's more, it becomes my build pipeline, my single binary that I go and deploy. There's a lot of value for that. We haven't got time, but at InterSystems, you'll see tomorrow, there's an experience lab that you can put your hands on it. We have a new cloud manager that does exactly that. It configures full infrastructure in AWS, Google Compute Platform, Azure, VMware, nothing, as long as you got an IP address and SSH connection, we can configure the InterSystems RSData platform. And of course, we do it very quickly, very efficiently because we use containers. Your dinner's ready. There's a lot more benefit and introduction. I can share the slide, there's no problem here, but in very few minutes, that's what the benefits of containers are. And so it's worth mentioning only two things. That we do have a passport to become the first class citizen of the container world. The first is ISC main. When you saw me doing a Docker run busybox date, it came up, and then what? It went to sleep. There was no process inside. There was no init or systemd sustain the container, right? So when you get a container from InterSystems, we have that process. We call PID1. Okay, ISC main, which by default start InterSystems Iris, but it does lots of other things. So you can pass parameter, you can run things before, after, and all kind of interesting things, and it logs stuff for us. And the second most important thing is because we've seen that containers are ephemeral, i.e. when I stop them, that's it, I've lost everything. What happens if I go version 2 of my application and I want to deploy? So I go version 2 of my container. So I stop the old container, bring up the new one, and what about my user credential? What about my security setting? What about my auditing? Anything that's basically is in %sys, where we got this new feature called durable %sys that allows you to do exactly that. So let me run the animation for fun. So it's version 1 of your container, and all you have to do is it's run according to what a Docker environment would expect. So I can pass environment variables, and the other thing is I can map volumes, so host volumes. Okay. And so all I'm saying here on my IC data directory, we have a series of IC underscore, environment variables. Okay, we got an extra one now with containers that says I want my %manager directory into this particular path, okay, which is mapped into a host file path. Which means if I come around with my container version 2, then guess what? You don't have to do absolutely nothing new. You use the same variables, so we know exactly where everything is pointed at, and say, yep, that's true. He's got the %sys right there, so I'm going to use it, and you don't see any difference, so you don't lose any of your settings. So that way you're able to be completely, to behave properly in the world of containers and really, make the most of it. We have several customers already using them. So we're very excited about this technology, and tomorrow you're going to hear a lot more about it with InterSystems, InterSystems IRS. Bedtime reading is always useful sometimes, especially when you can't sleep because you can't fix the VA problem or whatever it is with the code, John. Lots of good stuff that is happening around infrastructure and architecture in this world. And much of it is the Phoenix project is particularly developed that or talking about it is the DevOps paradigm. Okay, so me as a developer, I don't throw the code over. I say good luck to you. If you use the best of your system, the best system administrator you have, a configuration management tool, is like we're working together. Right? So I give you the code. Okay, let's factor it together. But see, everything comes much easier if you just see a Docker file and we read it together, right? And my sysadmin might say, oh, but what about that library is not secure? Oh, okay, well, let's change it. Let's install something new inside the container because I might need it for something that my application needs it. And so you work together, and that helps. And yes, in general, they are used a lot into the microservices architecture type of architecture solution. However, nobody will ever tell you off if you put a monolith inside your container because there aren't any rules. And there are, as I've tried to point out, many advantages already in doing that. Thank you. Any questions?
What are you using as the layering system for your containers?
Yes, say again.
What are you using for the layering system?
For the layering system?
Yeah.
So the base image? Are you referring to the base image?
Well, as you start your commits, what are you actually using for the layers?
Well, that is done automatically by Docker engine, actually, so you don't have to worry about it. But I can tell you what we use in terms of the two main images. Okay, so we base everything on the Ubuntu base image, just because it's one of the most secure right now as they come out. So right now we support a 16.04 LTS, the long-term support. We also like a lot their commercial proposition. You don't have to buy a license or what's it called, subscription, like Red Hat says, and you can go live with that. And then there you go, probably call them up and say, hey, I want a subscription right now. They're quite small, quite efficient. And on top of that, as soon as you start installing anything or copy, like I was copying my app.sh, okay, you're creating a layer. Okay, and all these layers are just hanging there really on their own. It's only when you do the commit at the end, of course, the Docker build, when you run Docker build, it does it for you, then it puts them all together. Okay, but you still can run like Docker history on a particular image, and you see the different layers of what they've done with it. Okay. So it's automated, and it's part of it. And by the way, this is part of a standard. I think it's very important to mention that it's called the OCI, Oracle. No, nothing to do with Oracle. It's the Open Container Initiative. Okay, it's the version 1 released in August this year. And it's very important because apart from Docker having donated quite a lot of code last year, the point is it dictates how a container image is formed, so the layers, okay, and when it runs, how it runs, and what it does. And behind the OCI version 1, standard, there are people like IBM, Microsoft, Red Hat, all the enterprise guys. So this is a technology that's going to stay here with us, and so we just wanted to jump on it. So hope that you can have fun with it too, and ask me if you and when you want to play. Thank you. Yes.
Luca, how is the cache licensing handled? Is that part of the durable %sys?
Yeah. So the license is still very much as we know it, and yes, it is still in that particular location. So it's up to you. One extra thing that we've done is with the ISC InterSystem main PID process that we've done. If you don't want to give the license out that you might purchase for a third party or an organization that you consult, you can pass the key on the command line. Okay, instead of burning inside the container,
Right.
Just extra options.
And that applies if you push, if you've created some container, you think this is pretty cool, I'd like lots of people to use it.
Yeah.
You obviously don't want to send it with your license in it.
Correct, right. Yes. So you have options. You can either burn it in. So if you're within an organization, your system is inside the organization, it's probably no point doing anything else. Just during your build process, you burn the whole solution inside. But if you're doing anything else, it's probably advisable to say, Docker run, my InterSystems is container -k or --key, and specify where to find the key. And what we do is inside the container, going back to the build stage, you can leave some variables. So there's one called IC package directory there, and that we maintain. So we can reference that. You can reference that too, and so we know where the managed directory is. And so we just copy there, and then we start the instance.
More questions?
By the way, there's a Docker version of Qt.
That's what?
There's a Docker version of Qt.
Oh, I'm sure there's Docker version of everything. Thank you, guys. Have a good evening.
So guys, thank you for joining this first UK meetup. Actually, we are looking for you to get your feedback if you needed more. We're not here in the next year, but sooner, if you like it. And Kara said that tomorrow we are starting at 8:45. So and now we are not finishing, so we continue all our conversations in the next room. There is a dinner with some drinks, and so let's continue with up. Thank you.
Thank you.